Let's break down one of the most powerful tools humanity has ever come up with. It's called the scientific process. And really, it's our engine for progress. It's how we make sense of the world, how we solve our biggest problems, and honestly, how we figure out what's real and what's not.
So to really get why this process is so important, we gotta look at the scale of the challenges coming our way. I mean, think about it. Within just a couple of decades, there are going to be over 8 billion of us living on this planet.
And at the very same time, our world is literally changing shape. Sea levels are rising, and that's a direct threat to coastal cities and entire island nations, places where millions and millions of people call home.
On top of all that, the stuff that fuels our lives, everything from the materials in our phones to the gas in our cars, is getting harder and harder to find. So yeah, the pressure is definitely on.
This brings us to a really big question, right? Looking at all this, how do we even begin to face a future that's this complicated? Where do we possibly start? These are the massive challenges of our time, and yeah, they can feel pretty overwhelming. But what if I told you we have a proven, step-by-step way to understand them and even solve them? Well, that's exactly where science comes in.
And that method is science. Now, before I just throw a definition at you, take a second. When you hear the word science, what pops into your head? A boring class you took in high school, a bunch of facts in a textbook, or is it something more?
You know, the best way to think about science isn't as a big book of answers. It's a dynamic process of discovery. It's an active, hands-on way of asking questions and finding reliable answers about the world by watching and by testing things out.
So let's unpack that, because this is the really cool part. At its heart, science is all about the thrill of discovery, but it's also a team sport. Data isn't meant to be locked away. It's meant to be shared so we can all build on each other's work. And here's my favorite part, the one that people always forget. Science is an incredibly creative endeavor. Seriously, designing a clever experiment takes just as much imagination as painting a picture or composing a symphony. Okay, so if science is a process, what are its fundamental building blocks? Well, it really just comes down to two things: data and interpretation. And understanding the difference between them is absolutely crucial. Data is simply the raw information we collect. It can be quantitative, that means numbers, things you can measure, like the rising CO2 levels in the atmosphere, or it can be qualitative, descriptive things you observe, like saying, hey, this piece of volcanic rock is dark and glassy. Both are just clues in the puzzle.
And here is a fantastic example of how data leads to an interpretation. Think of it like a detective story. The clue, the raw data, was these dead underwater trees found off the coast. Then, scientists connected that to another piece of data, old records from Japan about a mysterious orphan tsunami. So what's the interpretation? A monster earthquake must have hit the American coast back in 1700, causing the ground to drop and sending a giant wave all the way across the Pacific. The data told a story that was hidden for 300 years.
Let's bring this idea home with a super simple example. Just look at this chart. All it shows is a collection of data. Along the bottom, you have class attendance. Along the side, you have the final grade. It's just the raw info.
So looking at this, what's the story it's telling you? What's a simple interpretation you could make just from what you see here?
The most obvious one, right? The better your attendance, the higher your grade tends to be. And just like that, you did it. You did the core work of a scientist. You took raw data and you interpreted it to find a pattern.
Okay, so we have our building blocks down: data and interpretation. Now let's put it all together and see how the full scientific process really works, from beginning to end.
So, the process usually follows 3 main steps. First, you make an observation. You just notice something. Second, you form a hypothesis, which is really just a fancy word for a testable explanation for what you're seeing. And third, based on that guess, you make a prediction.
Let's try it out with a little puzzle. Here's our observation. We've got 2 bottles that look like they're just filled with water. A green cube floats in bottle number 1, but a red cube sinks in bottle number 2. Why? What's going on here? Well, we can come up with at least 2 possible hypotheses. Hypothesis 1, the cubes are different. Maybe one's made of a different kind of plastic that's more dense. Or hypothesis 2, the liquids are different. Maybe the cubes are exactly the same, but one of the liquids is denser. Both seem like totally fair guesses.
Now here's the most important part. How would you test this? Put on your scientist hat for a second. What's a really simple experiment you could do to figure out which of those hypotheses is the right one?
I bet you thought of it. The easiest thing would be to just switch the cubes, right? And if you did that, you'd find out the secret wasn't the cubes at all, it was the liquid. The first bottle had dense salt water, and the second one just had normal tap water. So our simple experiment proved that hypothesis 2 was the winner. And here's why that simple little experiment matters so much. That process we just walked through, observe, guess, predict, test, that is the exact same process scientists are using right now to understand climate change, to predict earthquakes, to find new sources of energy. It scales up from floating cubes to the entire planet.
You see, the scientific process isn't some secret club for people in lab coats. It's a way of thinking. It's a tool that's available to every single one of us. And yeah, the problems we face are complex, but the process for starting to solve them is actually pretty simple. It all just starts with curiosity and asking a question. So as you go on with your day, what's the first question you're going to ask?